And what we're going to do now is we're going to plot y equals 2 to the power of x. I'm going to ask Miss Shegog, if I may, what would be the values for y. So starting with x to the power of negative 4.
Yep.
0.0625
Yep.
to negative 3.
Yep.
0.125. Negative 2.
0.25.
Mm-hmm.
0.5. 1.
Yep.
2. 4. And 8.
Excellent. So, if we were to plot this graph, we'd start at 0.0625. So that's going to be really tiny, very close. So hopefully you'll get some lovely plot points like that. Much like when we were sketching the parabola, what you want to get is a very lovely curve that goes through here. So I tend to do one at a time. Hopefully you get a very nice, pretty looking graph. This is a form of what's called an exponential graph. It is otherwise used to model how bacteria grows or any small microorganism. Also, it can be used to look at population booms in certain towns and certain parts of history as well. And if I may bother Miss Mullins, please, if I could possibly get the values for each of these. So negative 2 to the power of x, what did you get first?
So for negative 4, I got negative 0.0625.
Mm-hmm.
Then for negative 3, I got negative 0.125.
Yep.
Negative 2, I got negative 0.25.
Yes.
Negative 1 is...
Sorry, pause just a sec. Negative 3 was negative 0.125. Oh, sorry, thank you. There we go. Thank you very much. So negative 3 was negative 0.125, negative 2 was negative 0.25. Carry on. Negative 1.
Negative 1 is negative 0.5.
Mm-hmm.
0 is negative 1.
Mm-hmm.
1 is negative 2.
Mm-hmm.
2 is negative 4. And 3 is negative 8.
Great. Much like we were doing with parabolas, remember we with a parabola would have our base template of y equals x squared, and everything else was a transformation of that one. Would anyone be possibly brave enough to tell me, compared to the graph we just did in the first one, what is the transformation? Mr. Roston, what are you thinking?
I'm thinking it was reflected
Yeah, and which axis shall we say?
into the x-axis.
Yes, it's been this graph is y equals 2 to the power of x, but reflected in the x-axis. And of course, the only thing that's been changed compared to between the two is, of course, the great big old negative sign at the front there. So this little negative sign makes it reflect in the x-axis. You'll probably notice why I wanted to make the emphasis of x-axis, because a little bit later we're going to see a reflection in the y-axis. Miss Stevens, could you perhaps help us fill us in for the values for 2 to the power of negative x, starting with negative 3?
How much would it be by reflected in the y-axis?
What was that, Mr. Daniels? In regards,
What do you mean by
yeah,
reflected in the y-axis?
yes, this graph is the same as y equals 2 to the power of x, but reflected in the y-axis. Because it's a mirror image the other way. So we're looking at zone 4 now, which is this lovely friend up here. So there we go. But 1.06. So we've got 1.06, so it's about... What they think is the transformation from the first graph. Miss Smith, what you thinking? Yes, that is correct. 1 unit. So translated 1 unit. And that's what that +1 here. +1 means moved up 1 unit. If it had a minus sign, it would mean it's moved down. Now, for year 10 standard, we don't need to worry about moving left or right, which, if you're ever interested, I'm happy to tell you about that. But otherwise, just moving up or down.
Isn't it simple?
It's fairly simple. It's just that I didn't want to bombard you with all the things. So that's all.
Would it be just as simple as doing like a bracket?
It would be brackets up in the power. Okay. So if that said 2 to the power of x minus 1, that would be moving it
so
to...
it's like the regular
Yeah.
ones.
Yes.
Okay.
But it's just would be up in the power. Great. So, yay. We know that if we go back to our opening information, I want to introduce you to a concept called an asymptote.
Is it totes legit?
It is totes legit. It is asymptotes legit. And what I'd like you to do is I would like you to, as a group here, we're going to go and fill in this table where you're substituting each of these numbers in for x. Now, when you do this in the calculator, if you've not encountered this before, I would like to introduce you to something which is referred to. It's got a little small e. And I'm going to start by doing 2 to the power of negative 100. So 2 to the power of negative 100. And what we'll do, we'll get it off standard. We'll get it in a decimal form. And what you'll see is you'll see it listed here as 7.886 e negative 31. Has anyone seen that e before in a calculator? Put your hand up if you've actually seen it or know what it means. Mr. Schwab. Well, that's what the word would mean, but it's a very specific mathematical calculation. That e, yes.
Is it Euler's?
Not quite. What that little e actually means, it means times 10 to the power of. So what this is actually saying is that for when x is equal to negative 100, this is 7.886 times 10 to the negative 31. What does that mean? What that means is that, if you might remember last year with exponentials or scientific notation, basically what this means, if I was to write this as a proper decimal, it would actually be 0.0000 for about 30 of them, and then 7886.
Oh, I remember you saying that.
Yeah. So, because if we go back 1, that would be the same as saying 0.7886 times 10 to the power of negative 30. There, or 0.07886 times 10 to the negative 29, and so on. So basically, it's 0.307886. In other words, it's a wee bit small. So that's, if you see that e, so e means 10 to the power of. So I would like you to go now and fill in the rest of these boxes, please. Okay, I'm going to now ask a few people to help me out, get some particular results. Tate, could you perhaps tell me what that answer is when x is negative 5? 0.0212? Or 312, thank you. Oh, yeah, that's fine. Alright, we'll make that 0.63 then. And then we'll do that. Great. Okay. Miss Price, could you perhaps tell me what it is when x is negative 6? 6. Okay, jolly good. Mr. Musgrove, could you perchance tell me what it is when x is equal to negative 10?
Is 9.77.
Uh,
I did wrong. It's 9.77.
Yep. So it'd be 9.6, according to me, 9.66, because times 10 to the negative 4. Mr. Gebbing, have you done negative 15 for me? Yep.
9.536. I didn't round anything.
2 to the negative 15.
It's no, I've read the 21. It's
Ah.
3.051.
Yeah, 0, yeah, 5, 2.
Times 10 to the power minus 5.
You are spot on. Jin, 10 to the negative, 2 to the negative 20.
9.537 times 10 to the power of negative 7.
Yep. There we go. Mr. Newen, what have you got for negative 50?
Did I get it wrong something? But I got 8.88.
Yeah, that's
Yeah, no, that's correct. 8.882 times 10 to the negative 16.
That graph is
It would be. Luckily, we don't need to plot it. So now the question is here. It says here, what number is y approaching when the value of x is becoming more and more more negative? Now, Mr. Daniels, you were suggesting that it was more obvious than you thinking you were worried that it may have been. What value is y becoming?
0.
It's getting closer to 0. And that's what the definition of an asymptote is. An asymptote is a part of the graph that cannot possibly exist, no matter how close you are to it. You'll notice here in our previous graphs, if I can bring up my lovely previous graph that we got ourselves to plot, you'll notice that the lovely curve is getting closer and closer to 0, but it's not actually touching 0. And that is because there is an asymptote. An asymptote is where a function cannot exist. In other words, it's kind of like the equivalent of trying to divide by 0 and you're about to implode the universe by doing so. We've got... That's okay. That's all right. You're not in a green. You move on. Now, so an asymptote means that it's basically a part where the graph is no longer allowed to go. There is no value of x that you could substitute that would result in an answer of 0. For instance, 2 to the power of something cannot equal 0, because 2 to the power of 0 is equal to 1. We figured that out earlier. 2 to the power of negative 5 is not quite 0. So what it is approaching 0. And what we do is we do a little horizontal line like this. Now you'll see I'm making a little dashed line using my ruler.
It makes it closer to the first graph.
Yeah, this is the first graph on the first page.
Ruler.
You'll notice that this went up by 1. This was my 2 to the power of x plus 1. So that means there's an asymptote at y equals 1.
Oh, right. So it can move up and down with the graph.
Yeah, it does move up and down with the graph.
The little things.
The little dashed line,
Okay.
because it's not a physical line, it's just telling that graph will not go below that number. So, what I'm going to do now is, like we did with parabolas, that's the last time you'd ever have to plot one of these nonsense, so you don't have to get in a calculator and get 0.00001, try to put that on a graph. We're going to sketch the damn thing.
It was so disgusting.
So, when you're sketching an exponential, start with the asymptote. So where do you think the asymptote would be for just y equals 5 to the power of x?
0.
Yeah, it'd be y equals 0. What I'll do is I'll even zoom in so you can see my little picture here. Clearer?
And
Does it matter which side you write asymptote on?
Nope. Does not matter at all. What would be the y-intercept of this when x equals 0? What would be the y-intercept?
1.
It would be 1, because anything to the power of 0 is 1, because 5 to the power of 0 is 1. So I'm just going to label it there.
Oh, so it will always be a 1.
Guess what? I've drawn the graph accurately. That's it. That is literally it. Again, I would start with the asymptote. Remember, this graph has been moved up by 4. So where would the asymptote be now? At 4. You'll notice here I'm just putting the line randomly. I haven't even got a scale going on here. Now, what would be the y-intercept? When x is equal to 0, what would be the y-intercept? It would be 5, because 3 to the power of 0 is 1. 1 plus 4 is 5.
Wow.
4 to the negative x. Now, the asymptote is where?
0. Negative 0.
Negative 0.
What would be the y-intercept? When x is equal to 0, what would be the y-intercept? It'd be 1. Stop saying 7.
He's adamant it is negative.
Now. Now remember, what did we say about when there's a little negative sign in the index, when it's negative x, what's happened to the graph? Yeah, it's switched over. Is it reflected in the x-axis or in the y-axis? Y-axis. So it looks something like...
The day before I did it, she made a copy of it.
Okay. For this one, where is the asymptote?
Negative 5.
-5? I'm sure they have. Whilst you're there giggling, Jordan, because you might find it more difficult whilst you're giggling, what would be the y-intercept of 2 to the power of negative x minus 5?
Negative 4?
Pardon?
Negative 6.
Try, so we've got 1, take away 5, you were right the first time.
Negative 4.
Yeah.
So the y-intercept's always... Yes, of course it's always above the asymptote. Yeah.
Ah, not always, it depends on the reflection. Which one? That says negative 5. This is 0 to negative 4. 0.
I think it goes the same way the last one did.
It will do, yeah. No, because what's 2 to the power of 0 is 1. 1 take away 5 is...
Look at that. How good's that? That's it's a right angle. That is the most. It's a right angle. I never know how. It's a right angle.
Now, the other thing you'll find on this is that we should be working out what that the x-intercept is. However, because it is what would be referred to as a logarithm, I won't, because it's beyond the Year 10 course, so I'm not going to let that. But if you want to do that on your calculator, which is very easy to do, if we just go to, on the calculator,
The x-intercept, but never really well you. Oh, well, that one.
in this one it will. So if we want to find that x-intercept, what we can do is we can go to solve. Sorry? Yeah, there it is. So I'm just going to go to solve. You'll notice I put the negative x in a bracket there so it doesn't get confused. Oops. 0. And see, that's what the what it comes up as the exact value. So it's what's called the logarithm of E5 or over logarithm of E2. But I would suggest that you might want to get this a lovely decimal answer, and that would be a much more useful one for you. There you go. So, I'm going to label this as -2. You mean you haven't been watching them already?
Yeah. No, really? Oh,
Yeah.
that's so awful.
Not necessarily. It's either laughter or me going, listening up please, listening up please, listening up please. So we found this x-intercept. This x-intercept was found using the CAS. Miss Shegog, where would the asymptote for -2 to the power of x be?
Dude, that's actually.
No? Well, guess.
Yeah. We've got information.
What do you reckon?
Yeah, 0.
It is. Asymptote is at 0. Have faith in yourself and have faith in Miss Smith.
I thought you meant like the, yeah.
Miss Smith, could you then tell us where the y-intercept of this one is? -1. Because 2 to the power of 0 is 1, -1. So this is an example, I think it was Jordan, forgive me, if it may have been somebody else who was saying, is there ever going to be a graph underneath the asymptote? And when it's been reflected, yep, this is exactly it. Okay, where's the asymptote?
Negative.
-4?
Okay, I was waiting for something. Oh, whoops. Wouldn't it be this way? No, because it's like, look at this one. -5. It goes on. But that means
Where would the y-intercept be?
probably graph.
-5.
Okay, because 3 to the power of 0 is 1. -1 minus 4 would be -5.
Yeah, you're right.
Ooh, that's like waving it. Like goes.
Yeah, well, that's just...
Yeah, well, you can show it. Oh, sorry.
Yeah.
I didn't want you to change it. Like, yours is gonna split. Like, that's crappy. Dude, I did it the wrong way. I'm just like,
Oh, no, well, you know, I better make sure, you know, it gets to the Schwab seal of approval.
Well, I wouldn't want you to miss out on the Fields medal just to, just to...
Look, I'm well beyond getting a Fields prize at this point, a Fields medal. And there we go. That is sketching all the graphs, and therefore, that's exercise 9.6.